Hi everyone and welcome to this video on determining sample size. This is very much a calculator exercise, so you really need to have one by your side to be able to do these kinds of questions. It's virtually impossible to do by hand in most cases. So let's have a quick look at the question. We're just going to jump right into it. I'm expecting this is probably going to take a couple of videos because these questions can be quite long, so we'll just see what happens. A champion Australian cricketer, let's call him Gary, has a 4% chance of taking a wicket on any given ball bowled on the Indian subcontinent. So first determine how many balls he must bowl to ensure a 95% chance of taking at least one wicket, and then determine how many balls must be bowled to provide an 80% chance of taking at least 3 wickets. So, let's do the first part. Determine how many balls he must bowl to ensure a 95% chance of taking at least one wicket. Now, what we're looking for then is the probability of x being greater than or equal to 1. We want that to be more than a 95% chance. Okay. Now, the thing is, if we're going to do the probability of x being greater than or equal to 1, that means really we're dealing with the probability of x being equal to 1 plus the probability of x being equal to 2 plus and so on. It's going to go on for ages. So an easier way to do this would be to instead say, well, if the probability of x being greater than 1 is greater than 0.95, then the probability of x being less than 1 must be less than 0.05. And the only time when x is less than 1 in this case would be at 0. So really what we have is the probability of x equaling 0 must be less than 0.05. So the probability of x equaling 0, now we're going to use the rule for the binomial probabilities here. So we've got ncx times p to the x times q to the n minus x, which must be less than 0.05. ncx, well, we don't know what n is here, but I do know that x is equal to 0, and I also know that p is equal to 0.04. It was that 4% chance that we were given in the question. And because of that, I also know that q is equal to 0.96. So, subbing all of that in, I'm going to get nc0 multiplied by 0.04 to the power of 0 multiplied by 0.96 to the power of n minus 0, which is just n. And that has to be less than 0.05. So nc0, or anything c0 is going to be equal to 1, so that disappears. Anything to the power of 0 also equals 1, so that disappears. So we're left with a pretty nice equation here, which is 0.96 to the power of n, is less than 0.05. And there's just a little bit further to go with this, so we could take log of both sides. To be honest, I wouldn't waste my time though, because I would just chuck this into the calculator. So that's what I'm going to do. 0.96 to the power of x is less than 0.05. And I'm just going to highlight that, go to interactive equation inequality and solve. So you can see here that x is greater than 73.38. So I'll just write n is greater than 73.38. So therefore he must bowl, well, if we go to 73, we're not going to have that chance yet, so we actually need to go to the 74. And that is definitely ensuring there's that 95% chance of taking the wickets. Anyway, I might leave that video there and we'll do part B in the next one.